Hello, in this video I would like to discuss how to prepare calibration to apply color data in HDMapping. In Mandeye hardware we have a camera that is synchronized with LiDAR. It is available both in a product and in open source systems. You can see the camera in the photo here. The camera data is saved next to point cloud data in directory called camera-0. The file name contains timestamp and there is a metadata JSON that contains useful information provided by libcamera library. To apply color to point cloud, we need to perform two calibrations. First is intrinsic and second is extrinsic. Intrinsic calibration is to find internal parameter of the camera, its focal length, focal point and lens distortion parameter. It has to be done per device. This can be done with a program called Camera LiDAR Intrinsic Calibration. This program allows us to load multiple images of the checkerboard, then detect corners and find calibration parameter of the camera. Let's do that. We have images loaded. We will need to detect corners. As you can see, there are detection of our checkerboard, and with corners detected, we have to run calibration. After that, we have found parameters presented and also the reprojection error for all corners that were found. It is 2.2 pixels. That is not great, but acceptable for our next step. It is very important to save intrinsic.json file. That is essential for the next step. So let's save it. Let's close this application. And now let's investigate this file. As you can see, it contains necessary data. With intrinsic.json, we can go to extrinsic calibration. Extrinsic calibration is to find a transform of the camera with respect to LiDAR. To do that, we will need a capture of the calibration scene. I've chosen for this experiment a scene in underground parking and program called Camera LiDAR Calibration. Let's run our program. This program allows us to load an image with the with our calibration scene. We can zoom in and out with our mouse wheel. Next, we'll open Intrinsic from our previous step. As you can see, the image got rectified. And we have a first zoom in our 3D scene. And next we can add multiple point clouds. You should capture at least 3 point clouds to get a very dense map of the environment. Okay, you can see here that we have some initial alignment with intrinsic calibration. So the image is rectified, and we need to find how camera is oriented and translated to with respect to LiDAR. You can do that using sliders here. It will be drawn in real time, so it is quite responsive because of GPU code that draws both here and here. But I think more sustainable way is to use point picking and automatic optimization. So to do that, I will switch the drawing mode to intensity, and I will start picking points both in image and in 3D scene. Let's orient our 3D view to similar point than in our camera. So to pick the image, you can hold Shift key, and it will give you this nice loop, and the same can be done in 3D. You need to make sure that you point correct point, because here I want to pick the point on registration plate of this car, not some point on the bumper behind it. Next we'll get a point on here on let's make sure that we pointed it correctly. What's next? Maybe geometric center of this sign. I don't like that. I will remove it. Roughly the same. Okay, so I've picked few points, and you can see that if we start manipulating that, the numbers will getting smaller and smaller, but we can do it automatically. We have quite large error on this 0 point, but it is on the corner of the camera, and we probably didn't pick it correctly because it has very imprecise measurement, I believe here. No, it's precise. So I'm not sure why we get this much error. We can try to remove this point and see if we are getting better results, but I don't think so. So let's reintroduce those points. I think it's better. Okay, so with that we can do we can now also investigate the projection of the image on the point cloud, so we can get camera RGB mode, and that one allows us to take a look and investigate if we are happy with the results. So you can switch with Control key on Mac and Alt key, I believe, on PC, and we have some parallax error, which is expected because we don't have the location of the camera in the same place than LiDAR, but we should not observe that patches or places with the gradient in the intensity should travel, and we should observe this gradient moved in RGB space. So I think we have quite good results here, and those errors are our precision of the point picking. If we build some calibration scene with checkerboards, checker patterns and so on, I believe we can get much better results, but I decided here to do it in this underground parking, and I think we have good results. So last step is to save our calibration. So we click save calibration and we will be asked to choose location. So we will save in documents and we will save it extrinsic.json, and we can close this up and we can investigate what is in this file. So we have 4x4 matrix with extrinsic calibration, we have intrinsic calibration, and that it can be loaded. It also can be reloaded again. So you have option to open calibration, let me add image, and so you can actually rework the calibration. Opening image, so image, and let's add point cloud. Okay, also in this view you can see that we are getting, because we have only one camera in this device, we get only part of the scene colored here. Okay, I believe that is all what I want to show you today. In the next episode we will discuss how to colorize session, but the topic itself is quite large, so I believe it is good to stop here. Thank you very much for watching, and see you next time.